My name is Dennis Wright. Previously in books, blogs and videos, I have described a four-dimensional universe in which all time and all things exist simultaneously, a view that is now shared by many physicists. This video presents the conclusion of the hypothesis. When I theorized on how all matter and all time could occupy the same space and time, I realized that the universe's structure was heavily dependent on Planck's discovery of quanta, and how only specific, discrete packets of energy react one with another at any one point in time. This model not only explains how past, present and future all exist simultaneously, it also answers some of the most perplexing problems facing physicists today: dark matter, dark energy, why we perceive arrows of time, and the eventual fate of the universe. It is the tiny differences in each moment in time that enables past, present and future to occupy the same position in the space-time continuum. Quanta do not react with those of the previous or the next moment of time, even though they occupy the same position in space. Each new discovery in physics is described by a formula that enables other physicists to understand the reality behind each new concept. Newton described how gravity acts. Planck described how quanta behave. Einstein described how matter and energy relate. My formula is a fractal equation showing that time passes because it accelerates, and each moment in time is different to every other moment in time. No evidence has been discovered of new mass being created, so we conclude that all the mass of the universe was created at the Big Bang. However, 96% of the universe today is made up of stuff science cannot explain, although various theories have been presented to account for these anomalies. In an expanding universe, there is one thing that must change unless the mass of the universe is increasing, and that is its density and therefore its gravitational field. As the universe expands, its density and therefore its gravitational field decreases, and because gravity affects time, this causes time to accelerate. Newton described how gravity works, and using his formula, we can describe the strength of a gravitational field. We can use delta F to denote the gravitational field of the entire universe. The principle remains the same. The universal gravitational constant times the primary mass by the other interacting mass or masses. The real difference is that because the universe is expanding, we need to multiply the distance squared by Hubble's constant to account for the rate of expansion. This means that the universe's gravitational field is continually weakening. This weakening gravitational field can account for both dark matter and dark energy, but it raises a further concern. At the time of the Big Bang, there was neither dark energy nor dark matter, and these have been created by the universe's expansion and its weakening gravitational field. They now account for 96% of the universe. So it follows that 96% of the universe's life is now over. The universe is expanding at an apparently ever-increasing rate, and as the gravitational field is inversely proportional to the square of the distance, it follows that dark matter and dark energy are growing exponentially. These two forces can never equal 100% of the universe, but when the rate of acceleration exceeds the strength of the gravitational field, just like a satellite achieving escape velocity, the entire universe will evaporate into molecules that are unable to interact, to hold together and sustain the universe that we know today. This projected big rip or dissolution of the universe may not be millions of years in the future. It may be as close as a few years or even months.